Continuing with solving two-variable inequalities. The only way we solve two-variable inequalities is by showing the solution on a graph. Solve by graphing. The first couple are review problems. Y is greater than negative 3x plus 2. This one, y is by itself. This is in slope-intercept form. Remember, slope-intercept form, y equals mx plus b. We always graph the y-intercept first. B is 2. Y-intercept is 2. Slope, m, is negative 3. Slope we write as a fraction, and then we think through rise over run. Down 3 over 1. Down 3 over 1. And we do want to fill up the entire graph that's given. So we went down 3 over 1. If I'm going to continue this way, that's going to be up 3, left 1. Sometimes we have dashed lines, sometimes we have solid lines. Greater than but not equal to, because it doesn't have that line under it. This is a dashed line. And then we need to figure out which way to shade. We did that a couple different ways. The most basic way is if it is in slope-intercept form, which this one is, this says y is bigger than the line. I need the y values bigger than the line. The y values we're talking above or below. So if I want the y values greater than the line, my shading should be all of this up here. Example 2 is not in slope-intercept form. We had a couple different ways that we take care of it if it is not in slope-intercept form. This one says 2x minus y is greater than or equal to 4. (2x minus y is greater than or equal to 4. To find the line here, we are going to find the x-intercept and the y-intercept. And remember, we want to start thinking about where the line is. So the line, we don't need to worry about the greater than or less than. We're just finding the points that would make it equal. That's the border, the line between the shading and unshading. So to find the x-intercept, we put in 0 for y. If I put in 0 for y, it's going to say 2x equals 4. Divide both sides by 2, and I get x equals 2. My x-intercept is right here at 2. Y-intercept, we put in 0 for x. It says negative y equals 4. Remember, that's negative 1y. So divide both sides by negative 1. My y-intercept is negative 4. I mentioned earlier we are going to want to fill up the entire graph that's given, so we don't want to like draw a line like that. Let's draw a better graph than that. Notice to get from here to here, if I count my rise and run, I go up 1, 2, 3, 4 over 2. So let's continue that. Up 4 over 2. Up 4 over 2. I can get a couple more points down here by going down 4 and left 2. It's just one more point. This line is solid because it has this or equal to right here. And then to figure out which way to shade, we cannot just say greater than means above, because y is not by itself. It doesn't say y is greater than something. It says 2x minus y is greater than 4. So this is when we pick a test point. I am going to use the test point 0, 0. That is the easiest one to use. We can use any point on the graph as long as it's not on the line. So I would always use 0, 0 unless the line goes through 0, 0. So if I put 0 in for x and 0 in for y, it says 0 is greater than or equal to 4. 0 is not greater than 4. It's not equal to 4. This is incorrect. This is false. So I do not want to shade in my test point. My test point was on this side, so I want to shade in the other side. Example 3 is a little bit different. It looks the same. It is in standard form. 6x minus 2y is greater than or equal to negative 14. But if you go to find the x-intercept, I put in 0 for y, it says 6x equals negative 14, and divide by 6, we get x equals negative 2 1/3. And that's not going to be a good x-intercept. We're not going to be able to get other good points with negative 7/3 as my x-intercept. So the x-intercept, y-intercept method did not work well. When that's the case, we want to rewrite into slope-intercept form. So we subtract 6x from both sides. These cancel. Negative 2y comes down. Greater than or equal to negative 14 minus 6x. We're going to write the x first. Negative 6x minus 14. Next, we divide both sides by negative 2. And I get y. Negative 6 divided by negative 2 is 3. Positive 3x. Negative divided by negative is positive. 14 divided by 2 is 7. We did not have one that like this last class, but if you remember the rules for solving inequalities, if I multiply or divide both sides by a negative number, which we did here, we divided both sides by a negative number, what do we need to do? We need to flip our inequality around. It was greater than or equal to, we need to write it as less than or equal to. So again, that is because I divided both sides by a negative number, we needed to flip our inequality around. And now this is in slope-intercept form. It's very similar to example 1. Y-intercept is 7. Slope is 3, up 3 over 1. And we can continue by going down 3, left 1. This line should be a solid line. And because y is by itself, y is less than the line. I can think through the short, easiest way to figure out which way to shade. The line is bigger than the y values I'm trying to shade. I want the y values under the line. As always, if you prefer to use the method where you do a test point, that works also. If you put in 0, 0, it would have said 0 is less than or equal to 7. That is true. So we want to shade in 0, 0, and we did. Example 4 says negative 10x minus 5y is less than 20. Negative 10x minus 5y is less than 20. This one can be done either with x and y intercepts or by changing the slope-intercept form, which is what I'm going to do. Either way should get us the same line, though, the same shading. Everything should be exactly the same, regardless of the method you use. So we start by adding 10x to both sides. Negative 5y is less than 10x plus 20. Divide both sides by negative 5. Ten divided by negative 5 is negative 2x. 20 divided by negative 5 is negative 4. We do flip our inequality because we divided by a negative number. And now we graph. Y-intercept is negative 4. Slope is negative 2 over 1, down 2 over 1. This line should be a dashed line. And we want to shade in the y values bigger than the line. The y values bigger than the line are the ones up here, the ones above the line. A couple more quick ones that are just a little bit different. This one says x is less than or equal to 4. X is less than or equal to 4. If I do not have y at all, or in the next example, we don't have x at all, that means it's either a vertical line or a horizontal line. This one tells us I want x to always be less than or equal to 4. So we go to when x is 4. X is 4. Everywhere that x is 4, all these points have an x value of 4. All these points have an x value of 4. Notice we have a vertical line in this case. It should be a solid vertical line. And we want the x values. When I talk about x values, now we're thinking about left or right. The x values less than 4. 4 needs to be bigger than the x values that I'm shading in. So my shading should be to the left. And our last example says y is less than 5. If it's y that's by itself, y is less than 5. 1, 2, 3, 4, 5. There's my y is 5. I don't have any x, so I don't have a slope I can count. My slope is 0. If my slope is 0, we have a horizontal line. These are all the points where y is 5. This line should be dashed. It does not have the or equal to on there. And I want the y values less than 5, the ones smaller than 5, under the 5. There's our shading.